Välkomna allihopa, och klockan är ju jättemycket redan. Så vänligen ta en liten plats och sätt er på. Jag känner väldigt många, men Ali har jag inte träffat. Var är du? Är det jag som...
Kolla här.
Funkar min? Okej, jag tror vi börjar nu. Om ni kan mingla lite efter också i pausen och sådär. Så. Välkomna hit. Vi har redan tappat 5 minuter, men det gör inget. För det tar vi igen sen på fikat eller något, vad vet jag. Dags att inleda dagens seminarium. Årskonferens Hållbar sjöfart. Nu vet jag faktiskt inte vilken gång i ordningen, kanske 6:e. Säger du, Charlotte? I alla fall, varmt välkomna hit allihopa. Det är jättekul att se så många här. Det kanske är någon annan som tittar på streamingen också. The streaming must go on, fick jag ett mejl i morse från en som hade väldigt ont i halsen. Så håller ifrån Lars Niklasson som står där borta. För han är inte helt frisk. Lighthouse är jag chef för. Där jobbar då även nämnde Lars Niklasson och Elin Fränberg som stod och tog emot er. Elin vikarierar för Caroline som är hemma med en bebis. Och jag tror att de flesta av er vet vad Lighthouse är. Om ni inte vet det så kan jag säga att vi är en plattform för samverkan och kunskapsutbyte inom maritim forskning och innovation. Och vi har den stora äran att driva det här branschprogrammet. Det har vi gjort sedan 2019. Och det tackar vi för, Charlotte. Rickard Engström som ju är portföljordförande och också sitter på de här pengarna som vi använder. Han är också sjuk så att han är inte här. Utrymningsvägar, ingen idé springa ut där för då kommer man bara ut på en innergård. Utan om det händer något så är det ut genom dessa dörrar och så ut på parkeringen. Och vi hoppas att det inte händer något. Men är det så att det går ett larm så ska vi gå ut. För det, vad jag vet så är det ingenting som är planerat under dagen. Seminariet som sagt det streamas. Så tänk på det. När ni ska ställa en fråga så måste ni ha en mick. För att det ska gå ut i etern då. Och det ni säger kommer ju höras och sparas för eftervärlden. Kan ni också tänka på. Det kan ses på vår hemsida. Programmet ser ut så här. Det har varit lite ändringar och det kommer bli lite fler för det är fler som är sjuka. Men vi håller på till klockan 4 ungefär. Det vill säga vi ska sluta senast klockan 4. Men är det så att ni har jättemycket att prata om och frågor så kan det hända att det blir någon minut över. Förhoppningsvis inte. Men vi ska få resultat ifrån projekt som har genomförts. Vi ska få några spaningar ifrån Sjöfartsverket och till exempel inte då ifrån Svensk Sjöfarts Fredrik Larsson. För han fick åka till Genève. Jobwise. Och sen så kommer vi att prata lite om nya projekt och den pågående projektgenereringen. Ja. Så det var programmet. Och Charlotte, du som är den som leder det här arbetet i den här portföljen och är våran kund. Vad säger du?
Jag säger att det är mars igen och det är konferens för programmet Hållbar sjöfart. Jättekul. Ja, det är några år nu. Och som sagt, jag heter Charlotte Andersson, kommer från Trafikverket. Jag är portföljledare i forskningsportföljen för sjöfartsområdet. Och vi är alltså finansiär av programmet Hållbar sjöfart. Det här, men ungefär 2018 så konstaterade Trafikverket att vi ville öka satsningarna om forskningen inom sjöfart. Och då tog vi ett litet nytt grepp, det vill säga vi upphandlade det här programmet. Och det kan man tycka, är det så märkvärdigt med det då? Ja, men det är i alla fall ovanligt, för oftast när det gäller forskning så söker man bidrag. Ni får inga bidrag. Vi har upphandlat er som leverantör. Och det blir lite annorlunda med det. En sak som vi kunde göra då när vi skulle upphandla och konkurrensutsätta, det var att vi faktiskt kunde sätta det här som ett väldigt långt program. Så att vi visste från början att det finns möjlighet att det här programmet ska fortgå i 10 år. Vi bestämde att vi skulle göra en utvärdering efter 5. Och därefter skulle vi bestämma om vi skulle fortsätta i 5 år till. Och den utvärderingen gjorde vi. Och inte bara att vi bestämde oss att vi skulle fortsätta i de sista 5 åren. Vi skulle även utöka programmet. För vi tyckte att programmet hade gått väldigt, väldigt bra. Och att det kommer ut mycket bra projekt i programmet. För det var ju, eller det är ju så här, det är ju nyttan, det är ju resultaten som är viktiga. Och den här nyttan ska då gynna både området utifrån myndigheter men också näringsliv. Och vi ville att programmet skulle uppmuntra till delaktighet av aktörer från många olika områden i klustret. Och varje år så skickar Åsa in en årsrapport och där står det hur många aktörer som har varit med och varit delaktiga i projekten. Och i sista årsrapporten så var det alltså 178 aktörer har varit med i de här projekten på något sätt eller någon omfattning. Och det är bra jobbat för alla som är involverade. Men det finns säkert fler. Och då är en sån här dag jättebra. För här kan man ju då skapa nya kontakter. Kanske komma fram med nya bra idéer och hitta nya konstellationer för samarbete. Så att bara träffas kan ge mycket nytta. Men sen är det ju så att det spelar ingen roll hur duktiga vi är på att forska och hur många resultat vi får om vi inte kommunicerar resultaten. Och man kan säga med digitala kanaler så finns det ju jättemycket möjligheter att trycka ut nyheter. Men det har ju blivit mycket svårare att synas och höras också. Man får kämpa om att få höras och synas. Och det som ska kommuniceras kan ju ofta vara svårt att förklara. De här forskningspublikationerna som kommer ut från projekten, de är inte lätta att förstå alltid för gemene man. Och Lasse är superbra på att göra det lättförståeligt. Han intervjuar projektledarna och omvandlar texten så att fler kan förstå vad det faktiskt betydde eller vad man kom fram till. Så att väldigt styrka också med programmet. Trafikverket får ju reda på varje år hur mycket pengar som det finns tillgängligt för forskningen. Än så länge så har vi upp till 100 miljoner varje år. Och vi vill använda varenda krona. Vi lyckas nästan varje år. Förra året lyckades vi inte. Men vi tror att det var bara en tillfällig dipp. I år har vi lyckats redan att få in och teckna in alla pengar som finns. Och det är ju så här att vi kan ju inte säga att det behövs forskas om vi inte använder de tillgängliga pengarna. Så att vi måste se till att vi får in kvalitativa projekt så att vi nyttjar den ram som finns tillgänglig så att vi kommer fortsätta att få den. Så igen, jag hoppas att det kommer ut nya idéer från den här dagen när vi får höra resultaten. Så att tack igen, ser fram emot en spännande dag.
Tack så mycket Charlotte. Kan du få en stor applåd för det är ju... Det är väldigt roligt att höra dessa ord och det var väldigt roligt att få en utökad budget. Och idag ska vi visa lite vad man får för pengarna. Projekten som drivs inom hållbar sjöfart, de ska på något sätt adressera hållbarhetsaspekter och aktuella frågor från branschen. Och helt enkelt är det så att vi gör inga projekt om de som är med i vår prioriteringsgrupp från branschen, om de inte tycker att det är intressant. Då gör vi inte det. För detta är ju ett branschprogram. Men det kan handla om väldigt mycket olika saker. Och vi ska få se lite grann av det idag. Och det kommer att vara en hel del svenska men också en hel del engelska under dagen. De flesta slides är på engelska och sen om folk pratar svenska eller engelska, det är jag inte riktigt säker på. Men den första, vi har 2 talare. Den första det är Martin Alexandersson och Wengang Mao. Och de kommer att prata om varsin del av 2 projekt som hänger ihop. Och vi låter dem presentera bägge 2 och så tar vi frågor efter. Och första presentationen ska jag säga Martin. Du var här förra året och pratade också. Och du har jobbat på SSP, eller numera RISE, sedan 2011 med modelltester, simuleringar och dataanalys av fullskalig data. Och du har också varit industridoktorand på Chalmers med de senaste 5 åren. Med fokus på system, identifiering och produktionsmodeller inom fartygsdynamik. Så varsågod att presentera Grey Box Modeling of Ship Dynamics and Shipping Energy Efficiency.
Tack. Ja. Okay, hello everyone. I decided to take this in English because I thought that maybe there would be someone who didn't understand Swedish so well. But you may ask the question in Swedish because I'm capable of that language as well. Okay, so me and Wengang, we will do this presentation about grey box modeling of ship dynamics and shipping energy efficiency. The idea is that I will be presenting the part about ship dynamics, the identification of such models, and then Wengang will talk about the energy efficiency. But before we start, I thought I would just advertise this little book that I've written during the past 5 years. And I will present it in 2 weeks' time at Chalmers. So that will be an open defense, and so you can attend it in case you find this interesting and you want more. So my plan today was to give you a little piece of this book and share it with you, a piece that I think is particularly interesting. Yes. So first I wanted to give you a teaser or a motivation examples. Why do we need prediction models? Because my work is to identify prediction models using system identification. So this quote might be familiar to some of you, I guess. Houston, we've had a problem. Maybe you've even used it yourselves at some point. But the quote was from one of the astronauts on the Apollo 13 mission. This Apollo 13 rocket, the main engine had broken, and the astronauts were on a trajectory that would never return back to Earth, basically. So this quote, we had a problem, it was kind of an understatement. They were just going right straight into space. So the question is, how would they solve this problem for a rocket that is far away from Earth? Like, you don't have direct access to the rocket. And the answer is, of course, prediction models. They could use prediction models inside their big simulators. And they could run various scenarios to come up with a solution, like how would we bring our astronauts back home. So that was a very successful story, and everyone survived in the end. So I think that this is a very good motivational example, like why should we have prediction models for our spaceships, or maybe in our case we would like to have them for real ships. So it's very convenient when the real ship is perhaps far away. Maybe the ship is on the other side of the ocean, so we don't have direct access to this, but so we want to have something, a prediction model instead that we can play around with. And sometimes there are scenarios that maybe it's too dangerous to do something with the real ship, so then it's better to have a prediction model, because that's if we break that one, it's not as high of a problem. And also it can be a cost aspect. If you have a prediction model, you can run thousands or millions of simulations. Imagine doing that with a real ship. That would be really costly, like you have to run it for years. Okay, so there are mainly two types of prediction models for ships. The one that we can call the digital twin and the virtual prototype. In the digital twin concept, there exists a real ship somewhere where we can collect data from to build our model. In the other case of the virtual prototype, that is typically used before ships are built. The ship does not exist yet, so we have nothing to retrieve data from. So instead, nowadays, we use CFD calculations before the ship has been built to build up data that we can build models for the future ship. But I will be talking about methods that are related to the digital twins today, and that will be in the context of maneuvering of ships. So if we look at this zigzag maneuver that has been recorded for a ship, it goes in this kind of snaky trajectory. So the task here is, based on what this data, this trajectory, we should try to identify a system or a model that can predict this kind of motion or other kinds similar maneuvers. So the first step in my procedure is that I try to estimate the acceleration that is acting on this ship during this maneuver. Since we know the position of the ship, that means that we can kind of calculate the velocities and the acceleration by differentiation. So that is the first step. And then when we have the acceleration, we might also have a fair good idea of what is the mass of the ship. And if we have those two, that means that we can actually calculate what must the force have been that created this motion. And this is what we call inverse dynamics. And that is a very, very powerful technique. So we have kind of pre-processed our data, so now we can start to work with forces, which is much more convenient for an engineer to work with. So the next step here is that we established the kinematics of the ship. And I have been using a 3-degree of freedom model, so that's why we have 3 rows in this matrix. This might look a little bit complicated, but in fact these kind of terms are just inertia terms. And since we know the mass of the ship, that means that they are easily to calculate. So the only unknown forces are the damping forces. So if we move everything that we know from the inertia to the left-hand side, that means that we can express these damping forces. So before we proceed with this system identification, I thought that we could look a little bit more on the model. So I'm using a modular model where I say that the forces generated during the maneuver they come from either the hull or the rudder. These are the two main items that are in play during the maneuver. And we can also express that for the yaw equation like that. And then I assume a kind of model structure for the hull forces. So this is a data-driven model where I have some hydrodynamic derivatives that are being multiplied by the yaw rate and sway velocity and so on for the ship. So the task is to identify these parameters based on the measured data. And for the yaw equation, I have a similar expression. And you can also have something similar for the rudder model. And this is what I will be calling the physics uninformed model. So this is a model that kind of only relies on data, basically. However, I have proposed that you can also use a deterministic rudder model. So instead of using data for the rudder forces, we can kind of calculate the forces from the rudder instead, based on our prior knowledge of how we might know how a rudder usually works, and we can put that into the model. So we bring that prior information into the modeling. So this is what I will be calling the physics-informed model instead. So before we proceed, I thought that we could talk a little bit about identifiability, because this is something that I have realized during my research that is very important. And if we think about fingerprints, it's a typical way to identify people, right? There's like a one-to-one relationship between a fingerprint and a person. So if I have a fingerprint, we can match that to one person, and we know that that is the person who made the fingerprint. However, if we would look at footprints instead, that is much more uncertain way to identify people. Like a certain footprint could have been made by maybe 10 people in this room, for instance. So it's pretty hard to know exactly which person it is, and we need to be very careful how we measure the footprint and so on. So this is a problem, and then you have a hard way to identify, basically. So you can keep this in mind when we move on to the ship again. So here is the yawing signal again that we want to identify. So this is what we can observe from the experiment, basically. And then I have fitted the physics-informed model as well as the physics uninformed model. And in here it actually looks at like the uninformed model actually has a better fit to the data. There's a slight overprediction in the peaks because maybe this prior rudder model that we use is not perfect. But if we go inside these models and actually look what kind of rudder forces are these models creating, we can see that they are in fact extremely different for these two models. So how can it be that the total yawing moment almost looks the same while the rudder signals are so different? Of course, the hull forces are also completely different. As long as they sum up to the same thing, then we get the same thing, basically. So if you remember the analogy with identifiability, this is more like these two models, they have the same or very similar footprints. But we know that inside they are actually completely different individuals in a way. And if we run simulations with these two models for a zigzag, they get almost exactly the same result. So is this a problem then? We have two complete different solutions, but they have the same result. Of course, only one of them can be the correct one, of course. And as long as we only do zigzag maneuvers similar to this one, maybe both models will work well. However, there's something called generalization. Like if we go into something completely different, we also want the models to work. So as a first thing, I also made CFD calculations, because the CFD is kind of based on physical principles, and what kind of forces would you get then? And then they agree much more with the physics-informed model. So it seems that, okay, this must be a more physically correct model than the uninformed model. And what implications will that have? Then I tried to, what if we put on wind here? What will then happen? So here is a simulation where I added wind from southeast. And we can see that the two models now, they respond completely differently. Where the physics-informed model actually responds in a way that is more physically correct than expected. The other model does something that is very strange, actually. So this kind of shows the importance that even though two models might look like they both are equally good, maybe even in this case the uninformed model was better. But as soon as you go into something different, it can be a problem with the generalization. To summarize this, we saw that the prediction models are very important, but the identifiability can be a challenge. We saw something that is the difference between a mathematically correct model versus a physically correct model. And we saw that generalization can be a problem when we only focus on very good match with our data with a mathematically correct model. So the main takeaway message from this presentation, and what I've been focusing a lot on in this thesis, is that we should use prior knowledge from ship hydrodynamics to guide the system identification towards physically correct models with better generalization. So it's like choosing wisely from many solutions. We have many possible solutions to the problem, but if we go to our prior knowledge, maybe we can rule out many of the solutions that are actually not correct. So that was my presentation, and yeah.
Thank you. And thank you very much. And as I said, we will take questions afterwards. So if you, I don't know if you want to stand there or step down, then
I can stand.
But
here.
the next presentation will be given by Wengang Mao, and you see his title there, Professor of Maritime Operations and AI at the Department of Mechanics and Maritime Science at Chalmers. And you've been working on many EU and Swedish national projects on shipping energy efficiency, ship performance modeling, big data and AI for efficiency ship operations and ship safety. And you've had projects in this industry program before.
Yeah. Thanks, Rosa. Yeah. So thanks, Martin, also for the nice presentation, and then talk a lot about mathematics and also different modeling techniques. So I guess now many of you are interested about how these modeling techniques and also the mathematical models can be used by us for increased energy efficiency, reduce the emissions. And then within this industry PhD project with Martin, so as we can see, we have using 3 different kind of data. So the first is now the numerical analysis data from the CFD or from the first principles. And we also have the data from SSPA or from the experimental test. And then in addition to these 2, we also have the full-scale measurement data. And then regarding the energy efficiency and also the emissions. So in this project, we assume the data from the full-scale measurement is the ground truth. Okay? And then I will try to depend on how much of this ground truth data, like the full-scale monitoring data which we have. We can have different modeling techniques, as also Martin mentioned. So first, when we have very limited amount of the full-scale data, like after new ships, and then of course we have the first principle that can give us to generate the white box models, like the mathematical or physical models. And that can be also mainly used for the design purpose. But then when we have no models, we can also use them for the operations. And then when we have enough data, which means now they can cover all the operation scenarios for the ships and life cycles, then we can use in what we call the machine learning or the big data or AI models. What we call them is now the black box models. It is very powerful, but we do not know what happens inside. And then for most of the shipping companies, as we see, and we do not have enough data, and also we have a lot of knowledge from the test, from the numerical analysis. So in other words, now we're using the gray box models. So now we want to show you some examples about models for different the comparison of different models. So for this case, of course, if we are working on the energy efficiency, the key component is the relation between the power and also the ship speed. And then I have to also thanks for the Swedish shipping companies. We get a lot of full-scale data from them. And I will only show one case for this example vessels. So as we can see here, we have 5 years data from these vessels, and then we built these models. And as we can see from this vessel, maybe some of you know this vessel, they are using the constant and the power operations, as we see here. So it's always around 4,200. And when they meet different waves, the waves is something around 2 meters. And then we have using 2 different models. The first is now the black box models, as we can see, is the red cross. We also have the gray box models. So if we compare with now the speed predictions based on the gray box model and also the black box models, and then also the black curve is the measured speed over ground. As we can see now, especially when they meet the big waves, the black box models, even though we have 5 years data, they still cannot capture the trend of the full-scale measurement. But then for the gray box models, it is not perfect, which means now we still need some funding to do the further develop it. But then it can basically capture quite well about the trend of the speed. So that is the very good also indications. These gray box models can be the future for the ship energy efficiency for the operations. And now with these models, with these relationships, we also want to show you a few use cases. We have been using the gray box models and also the knowledge about ship dynamics, and then also using the speed-power relationship to design the decision support systems. And one of the cases, as we can see, is this ferry operated between 2 islands of Karlskrona, south of Sweden. If you look about these vessels, each of the trip is around half an hour. So in order to save time, this vessel will have 2 engines. So one is on the bow, and then one is on the stern. Of course, now how to navigate this vessel, one of the key issues is they must be in time. That means now the trip has to be half an hour, not more, not less. Okay? But then they have a flexibility is now how much power they has to put in the stern, how much power they has to put on the bow. And then since we are come from the naval architecture, we know it is more efficient if you put as much power in the stern as possible. That is also the measuring the data which we have. So as we see on the x-axis is how much power which is located on the stern. And then on the y-axis, it is the fuel consumption. So even though we know if we put power around here, all of them on the stern, it can have a lot of much energy efficiency. But they do have a lot of operations, which is now about 50% on the stern, 50% on the bow. So that we can see have quite a big difference in terms of the fuel consumption. Okay? That is now from the real operations by these vessels. And we see we have the model, And we also have the knowledge. So can we design these decision support systems to help the captains better operate this vessel? And we also have the opportunity to talk with the ship owners. And they have helped us to do the test around half a day. So in this test, we have also two different persons. One person is now the captains. For the captains, we tell them how to navigate the vessels based on the decision system. So as we said, we ask the captains put this and the power as much as possible in the stern, and also in order also to guarantee the ETA. That means now 30 minutes. And then they get a lot of instruction from the decision support system. We also have another one which is called the first mate. So we do not give any information to them. They just run business as usual, as we see. Sometimes they put 40% on the stern. So as we can see from here, and they have a very good trend. First one is now this, and the captains they navigate this vessel much more efficient. And then the second one also, if we're looking about the first mate, no instructions, so we have very big variations. If we're looking about all these half a day's experimental test, we can see they have something like 20% of the reduce of the power just by using these decision support systems. Okay, and then another one we have also used them for the voyage optimization of this short sea shipping. Is also from one Swedish ship owner. So that is the trip is around 2 or 3 days. So we also need to tell this the ship using the decision support system. So we divide the ships into different necks, and then in the decision support systems, we tell them how much power they have to put on each of the neck, which we are showing here. So here is now one of the results, as we can see here. On the top side, it is now x-axis, it is the time, and y-axis is how much power. And then the dashed line is the power from the real navigations. And then the one which is now the solid line is from the decision support systems. So as we can see, if we compare with the weather, from our decision support systems, when the ship encounters big storms, like 3 meters of the waves, and then the power is going down. And then when we have this when we have this small, very calm sea conditions, so the decision support system, they can tell them, speed up, to have the maximum power. And in the end, we found we have something like 5% of the fuel saving. So that is another example. And then the final examples, and it is the current investigations. I guess many people here are interested in the biofouling. So we're using these gray box models with the most advanced transfer learning, which is invented maybe 1 or 2 years ago. I'm not going to the too much details, but as we can see in this result, we can see on the x-axis, we have something around 3 or 4 years of data. And then on the y-axis, it is now the prediction of how much power will increase due to this biofouling. Yeah, so we have ISO standard, we have a lot of standard, but then often they have very biased. But if we're using the master transfer learning, which we have, as we can see, we can predict very well about how much of the trend. That means now due to the biofouling, we have a bigger increase of the power for the same speed. And the most important is now, for all these investigations, we can very clearly identify the how cleaning event. So as we can see here, they have one how cleaning or propeller cleaning, how cleaning, which we get from this data. So that is now the latest application case, which is now we use this model and the techniques. I guess now, all of the papers and also all the result has been summarized in the papers. And then some of them put on the Martin's thesis, and some of them you can look on the open literature. So now I'm going to the floor to Martin.
Well, I guess if anyone has a question to me or Wengang.
Could give you a big applause first. And also to tell you that, of course, you will also give us reports that we will publish. That's part of getting funding from this program. So does anybody have any questions? Do you see, when you show these results, are the ship owners, are they interested? What will happen, for instance, with the ferry to Wien? Are they doing something there? Or
I think they are. They're running much more on the stern, these days, and I think they will save a lot of fuel on that. Yeah, so that's good. Do something good for ship owners and environment also.
So, no questions. There's lots of naval architects and ship owners here that might or not agree with your... So what is the next step? What are you going to... Okay. I thought I could trust you. Björn, to come with a question. Just want to... It might work. Men jag har satt på den alltså, så om du provar att prata i den kanske.
I'm trying. Okay. Thanks, Åsa. Since you ask so eagerly, I have to ask. No, I just thank you very much for interesting presentations, by the way. When you presented the additional power compared to this one, yes, the percentage there, how do you explain that it never goes down to zero?
Yeah, because here we cannot go into too much details. Because you see, on the y-axis, it is actually not the power increase. It is a machine learning matrix to just see the percentage of the power increase. Yeah.
So your reference zero, is that
No.
sea trial or something?
Yeah, the reference there is sea trial. Yeah, we have the baseline. Thanks.
Thank you.
Okay. Thank you. Any more questions? Yes.
Thank you. Thank you for the really interesting presentation. I'm specifically fascinated by your results on the captain versus the first mate. And I'm wondering, what is the decision process for them? What are the considerations of allocating power between the stern and the hull? I mean, it's probably not a random process. Maybe they have different considerations like safety or other things. Here you only look at energy efficiency. Maybe they have other factors to consider to allocate powers into these different places. So curious. Thanks.
Thanks, Marty.
Yeah, I think you need to ask them. That would be an interesting project on its own, like interviewing the crew. What do they think about things? Like the human factor part of this. There's a lot to gain there, like the attitude towards things, and like the attitude maybe towards people like me who come and say, maybe you should run more on the stern. What do you think? Yeah.
And also, as I mentioned, a very important constraint is 30 minutes. Yeah, cannot be more, cannot be less. Otherwise, now people will miss bus.
Okay, thank you very much. Yeah? Ah. Okej, och vad vill du fråga Tobias då?
Tobias Husberg, Sea Strider. It was not the question, and I was actually the first one, what you didn't see me. It was more a comment, and I'm really glad about your result, because in our design we don't have propulsors like this, and every customer, they ask us, why don't you have 4 thrusters to get maneuverability? And I, over and over again, direct them to your results about the Wien ferry and show them that it's better with stern drive.
Okay, so your findings are already used. That's very nice to hear. Thank you. And good luck on the 4th of April.
Thank you.
And maybe some of those in here. but it did not work right now. Okay, so the next presentation, we're going to something completely different. Hydrogen blending in marine LNG, LBG fuels. And we should have two presenters, but one of them is at home sick. So Ali, very welcome. Ali from IVL, Ari Hediati. And you work as a project manager and technical coordinator. And he's also one of the experts on hydrogen at IVL. Welcome.
Thank you. I hope that you are hearing me well. It was here, so I put it here because I talk very loud. So I hope that you are feeling very good the first day of spring today, apart from shipping and anything else. Yes, as Åsa said, thank you very much for the introduction. Yes, I'm a researcher, senior researcher and project manager at AVL or IVL. And I also coordinate European projects and other stuff all the time. And one of the projects that I'm coordinating is about production of biofuels for shipping, the alcohol blends from organic waste. Because this is what I think personally is the way to go. So you already can guess what my opinion about hydrogen is. But anyway, I will not mix any personal opinion with the presentation. So let's see if that's the, yeah, oh, it's so small, but I think you can see that. So good then. Yes, my or friend or colleague, should I say, the senior researcher at Chalmers that is very unfortunately sick today. We had to present together, but anyway, I will take his part too. So Ali Hedayati from AVL, and yes, the project, thanks to Lighthouse and Traffic Work, gave us this opportunity to do this project. Assessment, big picture from above of blending hydrogen with LNG as a shipping fuel. So very brief, this is a very different presentation compared to the previous one that was technical and so deep. And a very, very nice one. And congratulations for finishing your PhD. Then I will just go through the project, backgrounds, the objectives, and how we did the project, and then some results, and then also, let's say, some conclusions and some future work. So without wasting time, yes, the project was a one-year project in 2024. Considering the vacations and time to write the report, not more than 7-8 months really of the actual work. So the main partners were IVL and the Chalmers, and we had a quite strong reference group too. Gotland Tech Development that had also a major major contribution to the project, really big thanks to them. Also Wärtsilä, MAN Energy Solutions, Norwegian Hydrogen, Furetank and Energigas Sverige. Yes, I don't need to talk about background. I'm sure that all of you know much better than I what we should do and why. But just to say that, okay, there are some the goal is to decarbonize shipping, and then there are, let's say, some solutions on the table. Some of them are already being implemented, some are assumptions, and then although myself I don't think that nuclear power is very much sustainable anyway. It's a way to cut CO2 emission, okay, or defossilize. So from that angle of view, then okay, I agree. And then here is the big question. Hydrogen. So then we actually a little bit, let's say, polished what we had to do and how, based on our interviews and let's say connections with the reference group, to answer some questions that from, let's say, looking at a big picture and answering some specific questions that are important. So finally we got to this. Is it a good idea to mix low carbon hydrogen, let's say green hydrogen, with natural gas as a fuel for ships' main engine, internal combustion engine, to cut CO2 emissions? So I will concentrate on this, cutting CO2 emission, not other aspects. But It's a very complicated question. It's not simple. There are a lot of things to consider. And of course, we didn't go through all, because then it's not a big picture and it's a much longer project than a few months. But however, we went through this. So I will read this for you, then you don't need to listen to me and also read at the same time. That is not comfortable. Then specific objectives. Pros and cons of blending hydrogen and methane from a technical, environmental and economic perspective. The optimal hydrogen-methane blending ratio means that, okay, how much should we blend hydrogen and LNG, volume or mass or whatever, to get to a good point based on, like, at the crossroad of technical, environmental and economic considerations. So, and then where to mix this hydrogen and methane? Should we mix it? We consider two scenarios. So should we have like LNG tanks and hydrogen tanks at the port? Then we mix and we blend at any ratio, and let's say we have the fuel ready, then the ship's bunker. So should it be there? Or we should have LNG tank and the hydrogen tank on board. So two scenarios. Then we will see what happens. Then, okay, this had to come like one after another, not to make it that confusing. Anyway, just look at this box. These are some assumptions, and these are what we assumed and we calculated to be able to get to some estimated numbers. These are not at all exact numbers, but they are very near to actual numbers of today. So we had a reference vessel, a ferry that was, let's say, it's short sea shipping. It's a ferry, so it's not intercontinental. So it's a ferry that operates between the main Swedish land and then an island in Gotland, all year round, running on LNG. So the maximum power output that can produce is it's an engine of 11.7 megawatt. Then based on that and the routes, the crossings, the fuel, LNG, consumption is 250 kilogram per nautic mile. That let's say leads to CO2 emission of around 700 kilogram per nautic mile, and then total CO2 emission 210 megaton. These are estimations, but near to the reality for that reference vessel only. Short sea shipping, I should repeat. Then, what is the system boundary? We just assume that LNG and hydrogen are available in the port. So we don't consider from where they are coming, how much CO2 was emitted to produce that green hydrogen and bring it at the port and store it at high pressure, whatever else, or LNG. Our boundary is that, okay, a ship is bunkering the fuel, and then it crosses, and then there is a tailpipe emission, CO2. Not NOx, not SOx, not other things, just we concentrate on CO2. So that is the system boundary. So assumptions. Production and distribution of LNG and hydrogen are not included. So this is important to remember, because then you have to assume that, okay, those numbers are excluding this. It's assumed that LNG and hydrogen in gas form, always 350 bar, this is our assumption, are available at the port. So we don't think that, okay, from where we should bring, okay, assume that it has been solved in the world, so it's available there. Then it's assumed that the mixture of methane and hydrogen are stored anywhere at 350 bar and ambient temperature. This is because of the physics and because of the available tanks today. There are some tanks, not that big for a ship, but anyway, based on the materials and technology. So these are assumptions. Maybe it can be 400 bar, maybe not more, or not less. But why not less? We will see. And then the pilot fuel is diesel. Okay, this is not, maybe you should say marine diesel fuel, not diesel, not the diesel that we put in our car. But okay, then here we go. This may look familiar. This is maybe not the first time that you see this. It's not a piece of art, but anyway, we should look at that. that this is the y-axis is how much we cut the CO2 emission compared with pure methane if we mix it with hydrogen at these percentages, volume percent, gas phase, not mass or not liquid, gas phase, volume. So important numbers. We can see that below 50% hydrogen in methane, decarbonization is really not beneficial, only 20% or 10%. Welcome to physics and thermodynamics, I always say. So then at 60% hydrogen, finally we get a meaningful number, 30% CO2 reduction. And if we mix 50-50, if we want to cut CO2 by half, then around 80% hydrogen should be in methane. So please remember, tailpipe CO2 emission, not other stuff. So if there is any CO2 emission somewhere else involved for hydrogen or for bringing LNG from somewhere to here or from biogas plants, then this is even worse. I cannot say better, it's worse. So then, here we go. Significant fraction of the fuel blend of hydrogen and methane must be hydrogen to reach a meaningful level of CO2 reduction. And what do I mean by meaningful? Is it a personal? No, it's not a personal actually viewpoint. This is, let's look at the Fuel EU targets. For example, if the targets of 2025 means that, okay, 33% of hydrogen should be mixed with methane, so we already get to this target. And if we want to get to targets of 2040, then more than half of the fuel, volume-based, gas phase, should be hydrogen. And then, here we go also, there is a summary. And 50% of hydrogen in methane will meet 2040 targets. But it's only 25% CO2 reduction. That much of hydrogen, 25%. We will see why. But why are these numbers important? Here we go. These are important because more blended fuel must be burned to obtain an equivalent power output as compared with LNG. And it's because if you now look at this graph, this is not made by me, this is, you can find it even on the internet, but I need to bring it to say why I'm saying that. So this is the energy, the y-axis is the energy density, the volumetric energy density, megajoule per cubic methane, cubic meter, and here is the pressure. So the line which is here is methane at room temperature. So yes, of course, higher pressure, higher volume density based on unit of volume. And then here is hydrogen. So any blend will be here in between, which is less than methane. What does this mean? It means that if for a distance you had to burn 1 cubic methane of LNG, not LNG, only methane, now you have to burn 1.5 cubic meter. So emission reduction is not linear. Well, again, welcome to physics and thermodynamics. This is what win. Physics win. So this is this. And then here we go. 2 examples. And he did this number up there is LNG. So here we can see that at best we can get to, for example, 10,000 megajoule per cubic methane if we compress methane to 300 bar. But then suddenly LNG breaks everything. 20,000 megajoule per cubic methane. So think of the crossing and the amount of energy that you need to put into this engine to do a one crossing. That's why it's important. And then I have 2 examples here. Imagine a tank of 1 cubic methane, so unit of volume. Then LNG contains 5 times more energy than pure hydrogen at 350 bar. So if you need the same amount of energy, your hydrogen tank at 350 bar should be 5 times bigger. Then if you say, okay, no, I will mix 50-50, then you need twice of the volume of 50% hydrogen in methane to provide the same amount of energy to the engine. So that's why these things are important. And then I will summarize some stuff. 50% hydrogen in methane blend cuts CO2 emission by almost 25% compared with 100% methane. More than 25% hydrogen in methane, which is pressurized, and we assume that it's 350 bar, needs new design of materials and equipment. You cannot retrofit. Cost and safety. So you need new materials for this. This is very high pressure hydrogen. So, and then less than 350 bar storage will decrease the energy content of the fuel drastically. More bunkering frequency, reduce the travel range, or maybe even not one crossing. So it's then impossible. And then here is the why. Volumetric energy density of hydrogen is 3.5 times less than methane. And remember that the fuel blend is stored in gas phase, so volume matters. And then increase the space, maybe up to twice at least, for fuel storage on board to be able to cruise the same distance. And then there are some solutions. Liquid hydrogen. So we make liquid hydrogen, so we even need a smaller tank compared to LNG, because liquid hydrogen has much higher energy density. It's the lightest element of the universe. So the problem can be solved. My answer is welcome to fight thermodynamics. And if you have really enough money to do that, you are welcome. But believe me that cryogenic liquids at around 0 Kelvin is really, really hard and costly to manage. So I don't think that it's a solution. So we even didn't consider, because the price and the cost just kills everything. So okay, I told you that 2 scenarios. One is import blending and storage of hydrogen, which means that, okay, in import we have an LNG tank and compressed hydrogen, so we mix them, and then the ship bunkers. Then, okay, what happens? Compressed hydrogen and LNG are stored separately at the port. Good. LNG must be gasified, then mixed with hydrogen. Sure, in gas phase, they cannot be mixed in liquid phase. Fuel blend, compressed and stored at 350 bar inland. Then fuel blend and hydrogen stored facilities need import. But the good news is that, okay, we can maybe use the LNG infrastructure already. But integration between the existing LNG infrastructure in the port, okay, yes, I just mentioned, it's a positive point. But then ships must have designated fuel blend storage capacity. So it needs a redesign. You cannot use the same let's say, the same designated space. And then the important drawback in this scenario is uncertainty if the vessel, the ship, can bunker enough fuel for even one crossing between 2 ports because of the energy content of the mixture compared to LNG. Then there is another scenario, onboard blending. So we have a liquid hydrogen or compressed hydrogen on board, and the LNG tank, we leave it there. So what happens? Okay, some assumptions and conclusions. Hydrogen is stored at high pressure and ambient temperature. No new tanks are needed for hydrogen. But LNG must be gasified, sure. Then the hydrogen tank could be very large compared to LNG tank. Remember this, that you must pressurize and go to higher, you must pressurize to get high energy density, volumetric based, and you must put a lot of hydrogen in methane to cut CO2. So you are here. So you are here. So it's much less energy compared to LNG or pure methane. Higher risk for shipping company to storage tanks with different characteristics in terms of a failure mechanism. And then the operator of the vessel maybe should be responsible fully for the investment and operational costs. So this is also the drawback of this. So then some cost analysis. Let's see, okay, how much does it cost today to do all this stuff? Only fuel cost, no tank cost, no storage cost, nothing else, only fuel cost. Our assumptions, this is the LNG price. This is what we have calculated based on our own projects and based on the best estimations in the world. This is much more than this in reality. But okay, we believe that green hydrogen price could be this for shipping. And then this is the CO2 allowance, okay, or let's say the penalty that you have to pay when you emit CO2, $90 per ton of CO2. So what we get, this is pure LNG today, right now. And then if we go to 100% hydrogen, then it's tripled. And then any mixture, this is only up to 25. I didn't have more space. So this is this, and then it just goes up. And remember that it's only fuel cost, and then 60% hydrogen should be mixed with methane, and then you get only 30% less CO2. So I think that we are running out of time.
Yes.
That's okay then. All right. Then let me do something else. I will just go to the last slide. Then, the blend requires large fuel volume to be supplied to the engine for equivalent power output to LNG. The technical challenges become more pronounced at higher concentration of hydrogen in the blend, and then the reduction potential was found to be limited if fuel blend contains less than 50% hydrogen. The high cost of renewable hydrogen remains a significant barrier, and then the blend as shipping fuel lacks economics viability as of today, currently. And then sharp cut in green hydrogen cost can open doors for further implementation of this blend. Actually, no particular optimal blending ratio. It depends on many factors. And then the place where the hydrogen should be stored also is uncertain, with a lot of drawbacks of each of the scenarios. So future advancement will talk. And then something important, any associated CO2 emission will reduce the benefit that we have already. And then I will just acknowledge a lot of colleagues, and we had also 2 master students that worked on this project. Many thanks to them, and then please ask questions.
Thank you. Oh, you have really been selling this. Seems like you think it's a very good idea, don't you?
Yeah, very good.
Okay, so
Never
do
do
we have
that.
any questions here? We're talking also about an existing ship, because if you build a new ship, you can make other
Other designs?
other designs, other decisions.
Yeah, definitely.
So please say your name and where you come from. Very short.
Igna Salmakaite, I will, so a colleague of yours, just maybe a brief reflection regarding the price of the green hydrogen that you quoted here. This year's innovation fund, vätgas hydrogen auctions, their bidding price for the hydrogen production was quoted as a €4 per kilogram.
Yeah.
And your concluding remark was, if the green hydrogen price goes down to $2 USD, there is a potential, and see it as a positive development for hopefully uptake of hydrogen as a marine fuel. So just wanted to highlight that there are positive developments taking place, and probably the green hydrogen price can even be further reduced as we move forward with such initiatives as the Innovation Fund has given, with a specific focus on the maritime transport.
Yeah, sure. So I didn't show you a sensitivity analysis. So it shows that only fuel cost, if it's not cut but by 80%, means that less than $2, not euro, $2 per kilo, it will not work. So I'm afraid hydrogen as fuel will be mandated by thermodynamics rather than legislations and other technological developments, because technology cannot change this, but nothing is fixed. We don't know. Time will tell. So if one day there is enough cheap green hydrogen, that's the way to go.
Is that the last concluding remark?
Mixed with personal viewpoints.
Okay, thank you very much. And you're allowed to talk to Ali out there, of course.
Yeah, please don't be afraid to talk to me.
No.
I'm open to
because now, nu pratar jag svenska igen då. Nu är det dags för det här. Kaffe, mingel, sitt på era stolar igen 11:30, är ni snälla? Så är vi i tid igen. Så varsågoda. Thank you. Så det är det svåraste av alltihopa, det är att få folk att gå in och sätta sig på sina stolar. Alltså du ska ta en handmick och gå med. Mikael, ja. Kan ni... kära Magnus Vikander, kan du gå och sätta dig? Så. Jag säger så, det är lite som min son sa till mig när han var liten. Det är så jobbigt med dig mamma för du lyder inte. Och det gör faktiskt inte ni heller. Så när jag går där och föser liksom, kom igen och gå in, då ska ni alltså gå in. That is the plan. Har du fått någon... För nu hoppar vi över på nästa lilla tema som är fortsättning, lite digitalisering. Modern digital enablement for more efficient digitalization on ships. Och det ska Mikael Johansson prata om. Och han kanske pratar svenska, men hans bilder är på engelska. Så vi är väldigt flexibla idag. Mikael Johansson, Head of Maritime Advisory Sweden and Denmark. Varsågod att presentera. Så ska jag hjälpa till med micken kanske.
Ja, det behövs någon teknisk support här.
Ja, det är tur att man är ingenjör alltså. Så kanske.
Nu funkar det. Super.
Varsågod.
Tack.
Och här är en sån liten blippgrej, eller vad det kan heta.
Också. En sån också. Vad bra. Tack för introduktionen Åsa. Och det väldigt flexibla överlämnandet av tekniken. Det löste vi ju. Mikael Johansson jobbar på DNV på advisory-sidan av den maritima verksamheten. Och jag ska presentera och jag tänkte jag kör det på svenska. Om någon tycker att vi ska köra på engelska så får ni hojta till. Ingen hojtar till. Då var det löst. Jag ska prata om ett projekt som vi har kört i Lighthouse-regi här under det senaste året, lite drygt. Som har en väldigt lång titel, så den behöver vi inte säga igen, för Åsa sa den ju redan, så det har vi löst. Bakgrunden till projektet som sådant var att vi har pratat om hur kan digitalisering vara ett stöd och föra shippingbranschen framåt under lång tid. Men mycket av diskussionen går åt kring väldigt relevanta frågor, absolut. Men autonoma fartyg, stora investeringar, den typen utav möjligheter som såklart digitalisering medför, absolut. Men kommer det här påverka den stora massan utav både fartyg i Sverige och på världsbasis? Kommer det påverka dag-till-dag-arbetet för de som jobbar ombord på våra fartyg i stor utsträckning, om vi tittar i någon typ av kort eller medellång tid framåt? Så om vi vänder blicken mot det istället då. Ja, där var väl vår spaning att den sidan utav verksamheten och hur digitalisering kan ha en påverkan är mindre i fokus än vad det kanske borde vara. Det här har ju också beforskats och kommit rapporter ifrån Svensk Sjöfart och Chalmers kring det här ämnet. Hur de digitaliseringsförsök som man faktiskt har genomfört kanske skapar mer frustration för de som jobbar ombord än nytta. Så målet var ju att se på, samla ett antal aktörer. Vad skulle man kunna göra för att påverka dag-till-dag-arbetet här och nu? Och kanske minska lite på den här frustrationen och minska lite på allt i stor grad fortfarande manuellt arbete som utförs ombord på våra fartyg. Så att där var startpunkten på något sätt. Hur skulle vi göra det då? Ja, det som vi tänkte var då att då får vi samla ett ganska stort gäng av olika aktörer i värdekedjan här. Projektet leddes ju av oss på DNV och RISE, Robert och Ted som jobbar med Mikael som inte är här idag. Vi hade med leverantörer av systemlösningar till sjöfarten, Maranix och Surikat. Vi hade med projektet de som levererar utrustning till fartygen. I det här fallet då, eller i det här projektet representerat av Manta och Marinflock och Berg Propulsion. Manta, för de som inte känner dem, är ju före detta Yara Marin och före detta Lean Marine också för den delen, i vart fall i stora drag. Vi hade också med såklart den slutgiltiga användarna, representerade av Flotell och av Stena Line. Micke sitter ju någonstans i lokalen där, vinkar lite försiktigt. Bra. Och för att kunna testa det här, för att göra tester av digitala lösningar i en live ombordverksamhet är ju inte alltid lika lätt att få till och kan bli lite svårt. Så hade vi också med Donsö Maritime Training Center i projektet så att vi kunde göra live-tester hos dem. En ganska bra grupp av deltagare representerar hela kedjan, kände vi. Om vi tittar på startpunkten då, vart är vi i sjöfarten? Ja, det som sjöfarten har varit bra på, det är att hitta lösningar till problem. Det är man ofta väldigt bra på. Och försöka förstå hur ska de här lösningarna interagera med varandra. Kanske mindre bra på det. Här har vi ett problem, här har vi en lösning och så går vi vidare. Och så skapar vi inte och tänker inte på hur kan vi göra det här så enkelt som möjligt. Hur kan vi återanvända data så vi slipper rapportera det på 48 000 olika format. Och som vi pratade om innan, kanske fokus på att lösa de här problemen och mindre fokus på hur implementerar vi det. Utan att vara allt för cynisk så är det ofta här får vi ett nytt system och här kommer ett mejl att nu ska vi börja använda det. Varsågoda, kör på. Så att där var lite startpunkten och nu spetsar jag ju såklart budskapet, men det finns väl ett uns av sanning i det i vart fall. Och det som vi också tänkte titta på då, vad är det som andra industrier har gjort? Vad är det vi kan lära oss av som verkar smart? Och hur kan vi använda det arbetet som är gjort och inte starta om från noll helt enkelt. Och ett mål blir också då att kunna korskoppla lite den här gruppen utav deltagare och få allas olika perspektiv på den här samma utmaningen och sitta runt ett bord och kunna diskutera det. Vilket också gav ett mervärde och förståelse för de här frågorna. Så. Det som vi också då insåg ganska snabbt att såklart hade man kunnat få till en mer digital miljö, hade man kunnat jobba på ett mer digitalt sätt, så ger ju också det helt nya möjligheter egentligen för alla de olika deltagarna. Är du systemleverantör, är du utrustningsleverantör eller är du operatör? Så får du helt andra möjligheter att samarbeta, att jobba på nya sätt och också skapa nya businessmodeller. Så det är ju också någonting som vi diskuterade i projektet, att kan man få till det som vi testade och piloterade här på ett skalbart sätt, så ger ju det en helt annan möjlighet att jobba tillsammans, att dela data tillsammans och att arbeta på ett helt annorlunda sätt då. Så att det var egentligen den första delen utav projektarbetet. Att undersöka de här frågeställningarna, att diskutera de här frågeställningarna i gruppen. Det som vi gjorde sen var ju då för att det var väl så gott så att ha den diskussionen och få alla på samma våglängd och se att här finns faktiskt gemensamma möjligheter för utveckling. Men det är alltid roligare att testa saker på riktigt. Så det vi gjorde då var att genom att vi hade möjligheten att jobba på Donsö Maritime Center, så tittade vi på hur kan vi i ett så verklighetstroget case som möjligt se på, kan vi koppla ihop olika system? Vi fick lägga lite av våra projektresurser på att skapa och egentligen få då ett API från den maskinsimulator som man har ute på Donsö Training Center. Men det gjorde att vi kunde då simulera och få ut operationell data ifrån den simulerade verksamheten. Kunna se på vilket format kommer den ut. Går den att förstå överhuvudtaget för en annan maskinvara? Det var ju en ganska, för de som inte känner DMTC så är det en ganska ny simulator, så det såg ju, om man ska se på hela industrin, relativt bra ut det som kom ut där. Men vi tittade ändå på vad är möjligheterna för att ha ett mellanlager för att tolka och använda den informationen som kommer ut ifrån automationssystemet, tolka den så den går att läsa för andra typer av system då. Och använda det i verksamheten. Så det var det första vi gjorde. Och identifierade vad är det som är väldefinierat, välkontextualiserat idag. Vad är det som vi har svårigheter att förstå för en tredjeparts mjukvara utav det som kommer ut utav ett maskinautomationssystem per idag. Så att utveckla det var första steget. Det som vi lärde oss då, det var ju att såklart, och det var väl något vi visste från början också, att själva kontextualiseringen av informationen är otroligt viktig. Om det som kommer ut ur ditt automationssystem är fullkomligt oförståeligt för en människa så kommer det vara ännu mer oförståeligt för en maskin. Det kommer man inte klara av att lösa. Så att den här aspekten av kontextualisering är ju otroligt viktig. Och i det här fallet så gick det att lösa både med hjälp av att det som kom ut av automationssystemet är relativt nytt, plus då att vi hade en mellanlösning som gjorde att vi kunde översätta informationen till någonting som en tredjepartssystem kan förstå. Det som vi också testade var ju då möjligheten att se på när vi får ut till exempel alarmpunkter. Hur kan vi använda dem för att trigga relevanta aktioner för de som jobbar ombord? Kan vi koppla, vi gjorde test med till exempel då jam rudder alarm. Kan vi koppla det till att när vi får det alarmet kan vi ge direkt och relevant information till de som jobbar ombord så att de får rätt information vid rätt tillfälle helt enkelt. Inte att man får ett alarm och sen ska man börja leta efter, är det i manualen det står nu vad jag ska göra? Eller står det i våran sms vad jag ska göra? Eller ska jag kolla efter en emergency checklista? Är det som säger vad jag ska göra i det här tillfället? Du kopplar specifika händelser till specifikt supportstöd för de som jobbar ombord. Och det fick vi utan jättestor effort att fungera på ett bra sätt. Så det är också kul. Och om det är hela saken, men det visar väl på att genom att arbeta på det här sättet så skapar man värden som går att få till på ett inte helt omöjligt sätt per idag. Om vi ska titta på vad vi ser som nästa steg i det här arbetet. Ja, som sagt var, det här med att kontextualisera information och göra den förståelig för en stor mängd system är en otroligt viktig fråga. Vi har jobbat, och jag själv också, med att definiera standarder under lång tid. Det som vi ser är att frågan är hur mycket av det som kommer behövas. AI-utveckling går så pass snabbt idag så kanske vi kan lösa väldigt mycket av den standardiseringsfrågan med hjälp av AI. Det hade varit spännande och intressant att se på vidare, men där i det lilla så tänker jag att här har AI en stor potential. Vi testade ju ett case som vi var inne på. Hur kan vi koppla ett alarm till relevant beslutsstöd för dem ombord? Det finns ju massa olika mer case. Koppla leverantörer till operatörer. Vilket underhåll som görs, vilken service som görs och så vidare. Så där finns det ju väldigt, väldigt många områden att undersöka vidare och se på vilka möjligheter till nya affärsmodeller hade det kunnat ge då. Så att det är väl det som vi har fått ut av projektet. Rapporten är i stort sett klar. Så den ska komma här snarast. Så att ett kul och ganska så hands-on projekt i digitaliseringens spår, vågar jag påstå. Ja, det var det jag tänkte säga.
Tack så mycket. Och de som var med i projektet, är de intresserade av att fortsätta och jobba tillsammans?
Får fråga med Mikael som är väl representerad idag, men jag tror det ska också sägas att
Du kan fråga Mikael då.
Ja,
Han sitter här. Genom Mikael.
Jag hoppar på honom helt oförberedd.
Jag tänkte vi tar...
Ja, det är ju helt enkelt så att det är två Mikael som kan svara på samma fråga av en tredje Mikael, så att det är toppen.
Ja. Ni förstår att för att vara med i det här projektet behöver man hitta Mikael.
Och det är ett krav.
Skämt åsido, från RISE vi är jätteintresserade av det här.
Och detta är alltså Mikael Hägg då?
Ja, det är Mikael Hägg från RISE. Vi är jätteintresserade av just de här frågeställningarna och det här var ett väldigt intressant, tror jag, första projekt som kan leda till andra saker. Men det är väldigt viktigt att industrin och andra är med också här.
Så då frågar vi nästa Mikael Junge från Stena Line.
Ja, Mikael Junge heter jag. Jag jobbar med digitalisering på Stena Line inom vår flotta. Jag tycker definitivt att det är intressant. Och om man tänker på digitaliseringen mellan olika system så vill vi definitivt sänka implementationskostnaden så vi kan accelerera implementationen. Och då är detta en strategisk nyckel.
Har vi en fråga från Björn?
Jag kan bara flika in innan Björn kommer med en fråga. Är också att några, utan att nämna några namn utav de som har deltagit i projektet, har ju sen gått vidare och insett att det här är liksom det sättet vi ska jobba. Kanske inte att koppla ihop, men att börja digitalisera det sättet som man arbetar. Så att det är väl ett bevis om något om att det som vi gjorde hade någon typ av värde i vart fall. Förlåt Björn.
Ingen fara. Björn Surral och Partners. Det är ju jätteintressant det här, för det har ju varit decennier med han jobbat med de här frågorna och nu börjar ju möjligheterna komma på det sätt som du beskriver. En fråga då, det är ju, om man tittar på retrofit så har du ju en utmaning och naturligtvis en högre tröskel. Men i vilken grad tittar man på det här från DNV:s sida till exempel när det gäller nybyggnader? För då har man ju en helt annan möjlighet att jobba från scratch.
Svaret på den frågan är väl, om man ser från DNV:s sida och rådgivningssidan, så är det klart att det här är ett område som vi jobbar med. Men det som är ju en utmaning med, man kan ju fråga sig varför går det så långsamt med digitalisering. Det återigen med att vara lite cyniskt. Sjöfarten är otroligt duktiga på att reagera på regelverk och att vara compliant. Här finns det inget regelverk. Det är ingen som säger att du måste göra det här. Det här handlar om effektivitet. Det handlar om att göra arbetsmiljö bättre både för landorganisation och sjöorganisation. Men det är ingen som säger gör det här annars. Och det är klart att det gör att utvecklingen går lite långsammare än man tycker den borde kunna göra. Men vi jobbar ju ett stort antal projekt där man inser att så vi arbetar nu är inte hållbart. Så här måste hända någonting. Den administrativa bördan för dem man borde är alldeles för stor. Det är alldeles mycket repetitiva uppgifter. Vi jobbar inte på ett effektivt sätt och i slutändan leder det ju till att vi har inte kontroll på vår verksamhet. Så det var väl det dåliga svaret. Ge oss ett regelverk så kan vi göra något från regelsidan från DNV.
Fast om det finns pengar i det också så kommer det också kanske att börja röra sig.
Ja, och vi ser ju att det rör sig och vi ser ju att mycket av det här som har varit stora problem innan kring standardisering och så vidare kan man använda AI för att sänka de trösklarna. Då blir det här helt plötsligt görbart på ett annat sätt. Alltså det är en ganska stor investering om man inte har det. Och etablera standarder och lång tid och mycket arbetskraft. Kan man sänka de trösklarna så är det klart att det kommer bli mer och mer attraktivt. Det gör det verkligen, och det pratar vi också om med i den här gruppen. Såklart så länge man fortsätter från industrins aktörer att erbjuda lösningar utan API-integration och folk fortsätter att köpa det. How far do we come?
Ja, men nästa steg kanske?
Kanske.
Ja, vi får se. Tack så jättemycket Mikael.
Tack.
Och det är ganska många olika saker som det här programmet gör. Olika frågor, så nu byter vi till något helt annat. Och det är Pejam Kallantar som är konsult på DNV som ska försöka få igång den där. Och ska vi se hur det går. Jag vill trycka på den. Och sen så unmute. Ja, kanske. Så.
Yes.
Och du har en examen i sjöfartsteknik, företagsekonomi och dataanalys. Och har jobbat med maritima operationer både ombord och i land. Och du ska prata om battery fire safety requirements suitable for smaller ES spaces on board.
Ja, precis.
Och du ska prata svenska eller engelska, det vet jag inte, men varsågod.
På engelska. Yes, today it will be in English. Maybe next Lighthouse I'll try Swedish. So this is a project about battery fire safety on board on smaller tonnage vessels. Now, this is a project that involved four organizations: DNV, RISE, Mariuf, who is a leading manufacturer of fire extinguishing technologies, as well as Candela, which is a sort of an off-taker in this new technology, sort of ferries, battery-powered ferries. I know that Sea Strider is also here today, and that's great. I'm looking forward to your comments and potential questions. Without further ado, the current regulations as we have them are about fire safety are mostly geared towards ocean-going ships, larger ships that have the ample space to basically install fire extinguishing systems in these big rooms, allowing for compliance with this IMO 1165 circular, which is the most relevant piece of legislation when it comes to battery fire safety. But when it comes to these smaller ships, we have challenges. For these ships to basically comply with the IMO 1165, they would have to come up with sort of over-designed systems, issues of space and weight, limited space, difficult to comply, essentially. So that's basically the question we had. The objectives was to try to investigate what would be some relevant fire testing requirements for a kind of water-based system, that can live up to the standards that we have set at 1165 for other purposes, and also fit-for-purpose rules. Basically thinking, can we come up with drafting a sort of adapted requirements, a set of requirements for this use case? The way we envisioned this project was to do a study of the current state of art in firefighting on lithium-ion batteries. Also, through workshops with manufacturers, come up with sort of enhancing the knowledge on battery fire extinguishing in these smaller EES spaces, confined spaces, and potentially propose test specifications that can be basically laying the groundwork for future studies and future regulatory development. So after this sort of the first phase of the project, which was the literature study was done, we designed a kind of hazard identification process where we basically recognized two relevant and interesting scenarios. One with a mist system or a flooding system inside a battery enclosure, and one with a mist system inside the sort of EES space. EES stands for electrical energy storage. So basically the room where the fire would be. So one is where the system is inside the battery pack, and one is when it's inside the storage system. And when we say the room, it's not really a room. It's really, when it comes to Sea Strider, or, well, I shouldn't talk about Sea Strider, Candela, those ships that we looked at, it's a really small, maybe a box. So these were the two, the hazard sort of is the same, is a fire originating from the battery cell itself. And this is the key challenge when it comes to battery fire safety. Is these sort of it's called a thermal propagation. It can lead to these sort of so-called unstoppable fires. And this really the question is, can we stop that, the thermal propagation? And this is the method basically going through this what-if scenarios. You think of the scenario, describe the cause, the concern, the measures and the barriers, what is the impact area, what kind of actions can you have, and then you go to another what-if. So the results of this, the literature study and the hazard analysis that we did with, well, I forgot to mention that it was done with experts from, the 5 experts from these organizations that I mentioned before. We tried to come up with sort of a draft of functional requirements for adapted firefighting systems in smaller EES spaces. So we recognize that the systems must suppress internal battery fires and prevent escalation. This should be a goal, regardless of how you get there. Another one was effective cooling mechanism for internal and external structures. And third one being a compatibility with both seawater and freshwater. We acknowledge that if there's a way to reach those two goals with seawater, that is acceptable. Since, you know, a question is, can a small size vessel carry really large amounts of fresh water? Is that feasible? Well, if they can use seawater and do, you know, reach the same goals in terms of safety, then that should be fine. What we also found out was that basically juxtaposing the water mist system against a sort of a flooding system. And we found that the flooding actually had some advantages over the currently more more applied mist systems. So the mist system has limitations, ineffective in stopping thermal runaway inside the battery pack due to the IP-rated casings. And these are basically a kind of protection against humidity and dust. I think IP stands for ingress protection. So this basically limits the functionality of the mist system. And also, again, there's a space question. When we talk about 1165, we have these big rooms for pump rooms, and machinery installations, and you have these huge, like, sort of sprinkler systems. So these are the ones that we are talking about. And on the other hand, the water flooding systems have better performance in confined spaces. So you basically flood a small space with water. And yeah, more practical for small spaces, obviously. Limited water, you don't need to, you carry the amount of water that you need to flood a small space. And we thought about a kind of a innovative solution, which is to enclose the battery in a box with an open top. And this essentially allows for the battery enclosure to stay submerged. And this is maybe not the best representation of an open top box because it has two sides, but maybe that box over there in the corner is like a better idea. It's just that the battery pack remains submerged. Yeah, so minimizes water usage and improves cooling capacity. Obviously, you know, again, a question of space. Less water, more effect. And obviously, disadvantage would be that it's not really doing anything about the structure around it or outside the ES space. So this is just about it's just submerging the battery pack itself. And then there's of course questions of complexity, design modifications. So you have to basically design a new system. We came up with a few recommendations, combining methods. We thought about potentially solutions where you combine both the flooding system inside the battery pack and maybe a sort of sprinkler in the ES space. So that's possible. You could